Let us see this question number 5. Figure is given. The mass capital M shown in the figure oscillate in simple harmonic motion with amplitude capital E. The amplitude of the point P is तर P पॉइंट दोघे स्प्रिंगच्या मध्ये दाखवलेला आहे. सो द अरेंजमेंट इज लाईक दिस. This is the rigid support. This is the first spring having spring constant K1. This is the point P joining the two springs. This is the another spring of spring constant K2, and here it is a mass M. So we have to find the amplitude of P. So this mass M has total amplitude A, and we have to find amplitude of this point P. Point P means it is the amplitude of spring number 1. When the mass M is moved through distance A, this position is denoted by A. This is the displacement A. Amplitude A. When the mass M is moved through distance A, then amplitude of its SHM is equal to A, and A is equal to x1 plus x2. This is equation 1. Now what is meant by x1 and x2? Where x1 is equal to displacement of spring 1 having constant K1, having spring constant, having force constant K1. x2 is equal to displacement of spring 2 having force constant K2. x1 is also amplitude of oscillation, of point P. x1 is equal to question mark. So this is equation 1. x1 plus x2 is equal to A. If F is equal to force applied to mass M to produce acetyl in it, then same force F is acting on both the springs, so that F1 is equal to F2 is equal to minus K1 X1 is equal to minus K2 X2, minus minus cancel, and therefore K1 upon K2 times X1 is equal to X2. This is the question second. So put this value of X2 here. The force constant of the two springs are different, therefore X1, X2 will also be different. जैसा K1 ज़्यादा रहेगी, ज़्यादा X1 कमी रहेगी, आधा ज़्यादा. So put 2 in 1. This is equation 2. And therefore, A is equal to X1 plus K1 upon K2 times X1. So X1 common into bracket 1 plus K1 upon K2. So X1 into bracket K1 plus K2 upon K2. So this is the value of A. So you have to find X1. So amplitude of the point P, X1 is equal to K2 upon K1 plus K2 times the total amplitude P. So this is the correct choice. So the correct choice is D. A पेक्षा कमी जायला पाहिजे बघू. D choice is correct. D is correct. Like this. There are various types of problem on no? So this is the mean position of the block M. When it is pulled through distance A, then A is the amplitude. The distance through which the block is pulled from mean position is called as the amplitude. So the two spring will also extend. This first spring will extend by X1, second spring will extend by X2, and X1 plus X2 is equal to total displacement A. So this is one relation between X1 and X2. The another relation is this. Now to move the block from O to this position A, extreme position A, some force is applied in this direction. Same force will be exerted on the two spring, and therefore F1 is equal to F2. So F1 is equal to K1 X1, F2 is equal to K2 X2 with minus sign. So this is the restoring force, like this. So K1 upon K2 into X1 is equal to X2. Put this value of X2 here. So we get the relation between A and X1. So X1 is given by this. जर X2 पाहिजे असेल आपल्याला तर इथे फक्त K1 आला असतो. लक्षात. Next, question number 6. 4 figures are given and which motion is not a second equal to V. Consider the mechanical vibrating system shown in the figure A, B, C and D. The vibrations are simple harmonic in. So simple harmonic motion कुठे कुठे असेल ती आपल्याला विचारलेली. So in case A, the figure is given like this. E. So it is the U2 parameter shown like this. So this is the level. When the pressure is applied to one of the level in the two arm will oscillate. So this total distance is taken as L, total length of the liquid column. So the liquid level in two arms oscillate simple harmonically, oscillate with SRM of period. Capital T is equal to 2 pi multiplied by simple pendulum surface formula H by D, where H is equal to L by 2. L is equal to total length of liquid column. Total length of liquid column. Liquid column. Therefore, A is hesitance. B like this. So it is the example of torsional oscillation. Torsional oscillation, and the disc perform angular hesitation. आपण theory मध्ये हे example बघितलेलं आहे. Therefore, B is hesitation. B is hesitation. Now, C. B is hesitation with period capital T is equal to 2 pi multiplied by under root I upon mb or C upon theta. C is a torque constant. C is a torque constant. Next example, spring and block. Spring and block M perform linear hesitation. With period T is equal to 2 pi multiplied by under root M by T. Like this. Therefore, C is hesitation. Now D. So the figure is shown like this. The resultant force R acting on the block M is downward, and displacement of M is also downward. Therefore, the motion is not hesitant. No force of elasticity, no restoring force, acting on the block M. Therefore, D is not hesitant. So out of A, B, C, D, only A, B, C are hesitant. Therefore, B choice is correct. Only A, B, and C are hesitant. It is not hesitant. Therefore, B is correct. According to the property of a system, the force and displacement should be in opposite direction. In this case, the resultant force R and displacement of the block both are in the same direction. They are not in opposite direction. Therefore, motion is not hesitant. Like this. Next, question number 7. The SHM of a particle is given by xt is equal to 5 cos 2 pi t plus pi by 4 in MKS unit. Calculate the displacement and the magnitude of the acceleration of a particle at time t is equal to 1.5 second. हे फक्त टी ची व्हॅल्यू सबस्टिट्यूट करायची डिस्प्लेसमेंटसाठी आणि ॲक्सेलरेशनची तर फक्त मॅग्निट्यूडच विचारलेली, म्हणजे तिथे मायनस एन आलं तर ते मायनस एन घ्यायची गरज नाही ती. हॅलो सर. सो displacement x is given. Displacement x at time t second is equal to 5 cos 2 pi t plus pi by 4. So this is the question in capital A. So at time t is equal to 1.5 second. Equation A gives x is equal to 5 cos 2 pi multiplied by 3 by 2 plus pi by 4 is equal to 5 cos into 3 pi plus pi by 4. Then x is equal to 5 times the cos of 3 pi by 4 की वैल्यू आपल्याला करता येईल मग cos A cos B minus sin A sin B. So we can calculate it separately. 3 pi plus pi by 4 is equal to cos A cos B minus sin A sin B. So sin of pi 180 is equal to 0, sin of 2 pi is 0, sin of 3 pi is 0. So this is 0 and cos of 3 pi is equal to minus 1. So it is equal to cos minus cos pi by 4. So expansion is this. This is equal to minus cos of pi by 4. So this is equal to minus 5 multiplied by 1 upon root 2. So x is equal to minus 5 upon root 2 meter. MK system we are using. So this is equal to minus 5 multiplied by root 2 upon 2 meter. So minus 2.5 multiplied by 1.414 meter. Therefore x is equal to minus 3.54 meter. This is the first part. The displacement is minus. So C choice is correct. D मध्ये value 3.55 दिलेले मग तिथे sin plus येते. Now we have to find acceleration. Second part. Acceleration F is equal to minus omega square x. So omega is equal to 2 pi. So minus 4 pi square 4 pi square multiplied by minus 3.54. So minus minus it will become plus. So this is equal to 4 into 4, 16, 1, 2, 14 multiplied by 9.87, nearly 10. So answer will be plus 40, 140 meter per second square. Acceleration F is equal to, this is equal to 2. So 1 and 2 shows that the correct choice is C. Therefore C is correct. C is correct. This is minus 0. Sin of 3 pi is 0. Like this. Next, question number 8. Actually, we can solve this problem by two methods. I will use both the methods. Starting from the origin, a body oscillates simple harmonically with a period of 2 seconds. After what time its kinetic energy is 75% of total energy. So what is given? Period is given. Period t is equal to 2 seconds. Initial phase alpha is equal to 0 at origin, that is at mean position. Small t is equal to 0. So first step, find x when AE is equal to 75% of total energy. 75% of total energy. Like this. So I will use both the methods. First, method 1. Displacement x is equal to a sin t plus alpha, but for mean position alpha is equal to 0, therefore x is equal to a sin omega t. Therefore velocity v is equal to a omega cos of omega t. This is equation 1. Therefore k is equal to 1 half mv square is equal to 1 half m a square omega square cos square omega t. This is equation 2. But what is the given quantity? But Ke is equal to 75% of total energy. Therefore 1 half m a square omega square cos square omega t is equal to 75 upon 100 multiplied by total energy is given, it is conserved. So 1 half will get cancelled. Therefore this cos square omega t is equal to 3 by 4. Therefore cos of omega t is equal to root 3 by 2. Therefore omega t is equal to cos inverse root 3 by 2. So 2 pi upon capital T into T is equal to, now cos inverse root 3 by 2, that is equal to 30 degrees. So pi by 6. Therefore pi will get cancelled, and therefore T is equal to T by 12 second. T की वैल्यू आपल्याला दिलेली, T is equal to 2 seconds. So 2 upon 12, that is equal to 1 by 6 seconds. So time taken is equal to 1 by 6 seconds. Required time T is equal to 1 by 6 seconds. So this is one method. The given relation is kinetic energy is equal to 75% of total energy. The total energy formula आपण direct use केला. Therefore A choice is correct. A is correct. Now second method 2. Method 2. So K is equal to K is equal to 75% of P. Therefore P is equal to 25% of P. Therefore K upon P is equal to 3. Therefore K is equal to 3 times P. So 1 half m omega square into bracket a square minus a square is equal to 3 times 1 half m omega square x square. Potential is the formula. So 1 half m omega square will get cancelled. So x square minus x square is equal to x square. Therefore a square is equal to 2x square. Therefore x is equal to a upon root 2. This is equation small a. But x is equal to a sin omega t plus alpha. Alpha is equal to 0 using A. So A upon root 2 is equal to A sin omega t plus 0. A cancel. So 1 upon root 2 is equal to sin of omega t. Therefore, sin inverse 1 upon root 2 45 degrees though is equal to omega t. Therefore, pi by 4 is equal to 2 pi upon capital T into T. Pi cancel. Therefore, T is equal to T by 8. Sorry, this is 3x square. Therefore, this is 4x square. So this is equal to x square is equal to a square by 4. So a by 2. A by 2. So this is a by 2. A by 2. And sin inverse a by 2 that is equal to 30 degree pi by 6. So this is equal to t by 12 that is equal to 2 by 12 that is equal to 1 by 6. So t is equal to 1 by 6 seconds. Time required is equal to this much. आन्सर सारखं ना इथे आपण x कॅल्क्युलेट केला आणि ह्या x साठी आपण t फाइंड आउट केला. इथे x कॅल्क्युलेट करण्याची गरज नव्हती, डायरेक्ट आपल्याला कॉस्टची व्हॅल्यू मिळाली. तर दोघी मेथडमध्ये आन्सर काही बदलणार नाही. आन्सर विल रिमेन द same. So 1 by 6 seconds. So if the period is 2 seconds, then after t is equal to 1 by 6 seconds, the kinetic energy will be equal to 75% of total energy, or potential energy is equal to 25% of total energy, or kinetic energy is equal to 3 times potential energy. Actually, this is the universal property of the SHM. At x is equal to a by 2, kinetic energy is equal to 3 times potential energy. We can use this property directly. So second part is easy comparatively by knowing this property. So we should know the equation for kinetic energy, potential energy and total energy. तर ह्या दोघी मेथडमध्ये तिघे इक्वेशन आपण यूज केलेले आहेत ते. नेक्स्ट क्वेश्चन नंबर 9. U is the potential energy of an oscillating particle and F is the force acting on it at a given instant. Which of the following is true? So U आणि F मधलं रिलेशन विचारलेलं आहे. Motion is the SHM. So we know this is the basic equation. In SHM, force F is equal to kx equation 1 in magnitude. So this is F is equal to minus kx. K is a force constant of SHM. X is the displacement from mean position. Displacement from mean position. Potential energy U is equal to 1/2 kx square is equal to 1/2 kx into x. So this kx is replaced by using 1. Kx is equal to minus f. This force has symbol Therefore, this is equation 2. Equation 2 becomes u is equal to minus fx, that is, so t times u, 2 times u is equal to minus fx, so 2 times x is equal to minus f. Therefore, 2 times x plus f is equal to 0. So this is the correct choice. So correct choice is given by B. B is correct. And B is correct. Like this. Next, question number 10. Again, it is related with energy relation. A particle of amplitude capital A is executing simple harmonic motion when the potential energy of the particle is half of its maximum potential energy. Then the displacement from its equilibrium position is. So we should know this basic relation. In SHM, E max potential energy as maximum value is equal to total energy is equal to K max. K max has maximum value total energy. So since what is given, the potential energy is half. Since potential energy is equal to 1/2 P max, therefore potential energy is equal to 1/2 of total energy. This is the given quantity. Now substitute the values. So in SHM we know that potential energy is given by 1/2 m omega square x square, and this is equal to 1/2 m omega square a square. So 1/2 m omega square will get cancelled, and therefore x square is equal to a square by 2. A is the amplitude. In problem, capital A symbol is used. Therefore, x is equal to a upon root 2. Therefore, when P is equal to half of P max, then displacement x is equal to a upon root 2. This is the answer. So potential energy is equal to 50%. So you can remember these two properties combined like this, and therefore the correct choice is D. D is correct. So remember these two cases. When x is equal to a upon root 2, then P is equal to 50% of total energy is equal to K. K and P are equal. Both are 50-50%. When x is equal to a by 2, then E is equal to 75% of total energy. P is equal to 100 minus 75, that is equal to 25% of total energy, or K is equal to 3 times P. या दोघांचा रेशो घेतलं तर आपल्याला व्हॅल्यू अशी बनणार. सो दीज आर द टू युनिव्हर्सल केसेस अँड इथे आपण वैसे वर्सा पण लिहू शकतो अँड वैसे वर्सा. So when K is equal to 75% of total energy, P is equal to 25% of total energy, or when K is equal to P, then we can directly substitute X is equal to A by 2 like this. So these are the energy relations in SHM. So again, the energy relations in SHM are given like this. We have also shown the graphical representation of this energy. This potential energy is a parabolic curve. This kinetic energy is also a parabolic, but it is an inverted parabola like this. So at distance x from the mean position, the potential energy is given by 1/2 m omega square x square, and total energy is always constant. It is given by 1/2 m omega square s square, where a is the amplitude. So in this case, the relation is given potential energy is equal to half of the P max. So maximum value of potential energy is equal to maximum value of kinetic energy, and it is equal to always the total energy. So total energy is given by this relation. So we get x is equal to a upon root 2. So potential energy is equal to 1/2 of maximum potential energy at displacement x is equal to a upon root 2. This is the universal property of the SHM. Similarly, this is one more universal property of SHM. At x is equal to a by 2, the kinetic energy and potential energy are like this. K is equal to 3 times potential energy like this. Okay, we will stop here. We will see the remaining problem in the next session.